Hey there, this is Zeb. I just wanted to do a YouTube series of videos on constrained optimization, constrained consumer choice problems with varying types of preferences and utility functions. So this is going to be the first video of the series. There will be more to come at some point. This one is going to look at a linear utility function. So here we have a utility function. It says that our utility is a function of how much of good 1 we consume, x1, how much of good 2 we consume, x2, and that's going to be equal to ax1 plus bx2, where a and b are both positive or at least non-negative real numbers. Now this is the type of utility function that you would expect to see if you had goods that are substitutes. So if goods are substitutes, they are used interchangeably. Of course, perfect substitutes are goods that are used perfectly interchangeably, but these may not be perfectly interchangeable because we've allowed for the possibility that they give two different levels of marginal utility, or two different marginal utilities. So for instance, the marginal utility with respect to good 1, or the marginal utility of good 1, is the derivative of our utility function with respect to good 1. That's going to be a, and our marginal utility of good 2 is going to be b. So you can see that these don't have to be perfect substitutes because a and b don't have to be the same. So it's possible that they are substitutes but are imperfect substitutes, and it's also possible that they're not substitutes at all. So let me make this point. If you see a utility function that looks like this, you cannot conclude just from that alone that these are substitutes. However, if you have goods that are substitutes, then they will have a linear utility function that looks something like this. So what we're going to try to do in this video is solve the consumer's optimization problem. And so the optimization problem of consumers is namely that they want to maximize, by choosing the correct amounts of good 1 and good 2, their utility subject to that budget constraint that they have, namely P1 X1, that is the spending on good 1, plus P2 X2, the spending on good 2, has to be less than or equal to their income. Now, because both of these are goods, and they both, or neither one of them are bads, and we have we have monotonic preferences here, we know that this is going to be this is going to be a equal sign. So we could actually just erase that and go ahead and write an equal sign here because we know we're going to fully exhaust our income on this. So what we need to do then is identify the optimal consumption bundle. The optimal consumption bundle, which we will call X star. Now, what we need to think about is when should a consumer want to purchase good 1 versus when should a consumer want to purchase good 2? Well, we know that the marginal utility of good 1 is A, and the marginal utility of good 2 is B. And so what we need to think about is kind of the consumer's overall bang for their buck. All right? So how would we think about bang for your buck? Well, bang for your buck would be your marginal utility divided by the price. That's how we can kind of think of the consumer's bang for the buck. So let's just imagine that the bang for the buck for good 1, that is A over P1, is greater than the bang for the buck for good 2, that is B over P2. So if this is the case, if the bang for the buck is greater for good 1 than for good 2, then we know that the consumer is not going to want to buy any of good 2. They're going to want to buy 0 of good 2. Now, how much are they going to want to spend, or how many units are they going to want to buy of good 1? Well, good 1 is a good. It makes them happier, so they're going to want to spend all of their income on it. They're going to fully exhaust their income. So we would expect to see here M over P1, because that's the number of units that we can buy of good 1 if we spend nothing at all on good 2. So let's think now about what they would buy if it were the opposite. Let's actually see if we can move some stuff here just a little bit. Let's move that there. Okay, so actually let's move it on up. All right, there we go. Okay, so now let's suppose that we have the opposite, namely that A over P1 is less than B over P2. So we can think of this as the bang for the buck of good 1 is less than the bang for the buck with good 2. So here we're going to have the opposite, namely that they want to buy 0 units of good 1 and they want to fully exhaust their income and buy M over P2 units of good 2. So those two cases are relatively simple. These are relatively simple cases. Let me see if I can erase this and move it down. I need to move this down a little bit. So now we need to think about what we get when the bang for the buck is the same for both goods. So A over P1 is equal to, and I probably actually should move this a little bit. Okay, I'm probably going to need a little more room here. So A over P1 is equal to B over P2. So this is where the bang for the buck is the same for both goods. Well, if this is the case, then we're really indifferent as to whether we buy good 1 or good 2. So what we will say is that we can consume some amount T of good 1, and we'll say that T is in the open interval from 0 up to M over P1. So what in the world does that mean? Well, that means we really don't care if we're consuming good 1 or good 2. Now, we could consume 0 units of good 1, or we could consume all of our income. We could spend all of our income on good 1, in which case we would buy M over P1 units. So we're going to consume something in that interval. Well, then we've got to ask the question, well, what does that leave for us to consume elsewhere? So that's something to think about. All right, so we can figure that out by looking at our budget constraint. So we know that we're going to spend all of our income on the consumption of these two goods. And so therefore, whatever we don't spend on good 1, we will spend on good 2. So let's write our budget constraint. So we get our budget constraint is P1. X1 here is going to be T, because we have just said that the amount that we consume of good 1 is T, plus P2 X2 is equal to M. All right, so now what we need to do is we need to solve for the amount of good 2 that we want to consume, given that we're consuming T units of good 1. So let's start off by dividing everything by P2. So we get P1 over P2T plus X2 equals M over P2. And now we're almost there already, right? From this, we can see that X2, we'll call it X2 star, that's the optimal amount of good 2, is just going to be M over P2. That is our income minus, or that is how much we can buy if we only buy good 2, minus P1 over P2T. All right, so there we have it. Here we have the amount of good 2 is going to be M over P2. That is how much we would buy if we spent everything on good 2, minus how much we actually spend. Now we've got to consider how much we can afford of good 2, given that we spent some on good 1. So we've got this minus P1 over P2T here. And so there's our optimal consumption bundle. All right, so this is kind of a nasty looking thing, right? But this describes the consumer's choice problem in this situation with a linear utility function. Let's think about it in terms of the indifference curves really quickly. So I will move this stuff up out of the way. So let's draw some indifference curves. So here we've got x1 and x2. Let's actually start with our budget constraint. And so, well, let's start with the indifference curves. So here are here's an indifference curve, right? Now remember, the slope of the indifference curve is going to be the marginal rate of substitution. So the slope of the indifference curve is going to be the marginal rate of substitution, which in this case is negative a over b. And the slope of our budget line, which we're about to draw in, so the slope of the budget line is always going to be equal to negative P1 over P2. So here's an indifference curve. Right, now let's draw a budget line. So let's suppose that this is our budget line. Right, imagine that's linear. Right, what is the optimal consumption bundle? Well, we see that this point is the highest level, the highest indifference curve we could be on given that budget line. All right, so what do we know here? We know here that the bang for the buck for good 2 is higher than the bang for the buck of good 1. Right? So that is that our budget line has a steeper negative slope than does our indifference curve. All right? Now, imagine that that were not the case, that this were our budget line. If this is our budget line, well, now we actually can consume a point right here. Let me draw it in yellow. We can consume this point, and that would put us on an indifference curve that looks like this. So this would be the highest indifference curve we could be on given this new budget line. Right? So this would be the case where good 1 has the higher bang for the buck. Right? Now, if we imagine the situation where our budget line looks exactly like this, right? If this is our budget line, then we see that in this case, negative a over b is equal to negative p1 over p2, or in other words, a over b equals p1 over p2, or if we wanted, right, we would have that a over p1 equals b over p2. So we can do that. So in this case, you don't care whether you're consuming this point or really anywhere in between. Anything in between here, any bundle along that line is going to be just as good. And so you're going to pick some amount. Let's say you pick this amount of good 1. We will call that T. Right? It is between 0 and m over P1. And then you're going to know, based on how much you've spent on good 1, exactly how much of good 2 you can afford. So that's going to be then m over P2 minus, so this amount is going to be minus then P1 over P2, the ratio of the prices, times T. So that's going to be this value. So we get this ordered pair here, T comma m over P2 minus P1 over P2 T. And in this, at this bundle, right, here we have that we want to spend all of our income on good 1 and buy nothing of good 2. And at this bundle, we have the opposite. We want to buy nothing of good 1 and spend all of our income on good 2. So there we have it. I hope that makes some sense and helps make constrained optimization with linear preferences a little bit easier. In the next video, we will talk about how we optimize this, or how we make this consumer choice given some other preferences. Thank you for watching.